I'm Engineer Bonifacio Lana Jr., Vice President for Customer Service and Engineering Services. I am 50 years old.
You may sit down if you want, sir. Just for the benefit of those here present, ipapaliwanag po ni engineer ang kanyang kung para saan po itong application at everything under the sun about the application. Afterwards po, pwede po tayong magtanong. Okay po? Sana po, just make it as simple as possible so everybody can understand. Right? So, may proceed ka sa engineer.
Again, good morning. For the expository presentation, I will be presenting the relevant activities and timelines, which is the first part. Then the second part is the brief background on the foundation of OEDC distribution system. And then the third part is the application itself, the projects, why we need to implement these projects in relation to the problems that we encountered in the distribution system. And then, actually, we have two types of projects classified into two. One is for the billing and collection, and then the second one is for the improvement of distribution system reliability, safety, and efficiency. For the timelines, on April 7, 2014, we filed the application before the ERC. And then ERC issued an order, a notice of public hearing on June 20, 2014. Then, for the compliance with the directives of the order, on June 23 and June 30, 2014, we publicized the notice of public hearing in Manila Times and Malaya Business Insight, respectively. And then, the furnishing of copies of the order and notice of public hearing to the Office of the Solicitor General, Commission on Audit, and Committee on Energy for both houses of Congress through registered mail. It was done on June 24, 2014. Then the furnishing of copies of the order and notice of public hearing to the offices of the Governor of Zambales and the Mayor of Olongapo City. It was done on June 23, 2014 and June 24, 2014, respectively. And then the posting of application, order, and notice of public hearing in ODC bulletin boards in our offices, it was done on June 24, 2014. Then the publication of the notice to customers in the Subic Bay News, a local newspaper in Olongapo City, it was done on July 1, 2014. So in the next part of my presentation, I'll be presenting brief background on the foundation of OEDC distribution system. By the way, this is the system of OEDC, formerly PUD, operated by PUD. Actually, we only have one supply from NGCP. Through that supply, we have 69 kV line serving these three power substations, namely one in Cali substation, which has capacity of 10 MVE. Then in CBMU substation, which has two power transformer at 5 MVE each. And then at Mercurio substation, we have two power transformer at 15 MVE each. So this system, we have two. Please take note that we have two primary voltage. We have 13.8 kV lines, and then we have 4.16 kV line. So all in all, we have 8 substation feeders, 13.8 kV, 7 feeders, then 4.16 kV, only one. And then, as noticed and observed, the wire sizes of the substation feeders, which is supposed to be the backbone lines of the system, it's only 4.0. And smaller sizes, there are splices in between. These are the problems that we encountered before, and when OEDC started operating the system. First, on high system loss, a very high system loss, 37 The system loss cap, by the way, for the distribution utility privately owned is only 8%. Meaning, we only allowed to recover until 8.5%. So the excess of that losses will be absorbed by the distribution utility for OEDC. So in our this estimate, we have break down this system loss into two, which is the technical one, which is parang natural. No? Natural siya. When there is a process of transformation from high voltage to lower voltage, there is always a system loss. At the same time, when we transmit a power from one point to another point, there is a natural loss. And then the second part of the losses is the non-technical one. In my way, it's parang artificial, no? Artificial. 25%, so mataas siya. So in our analysis, this is due to the following. One is due to inaccurate meters. Second is very high incidence of electricity theft. And then there are many unregistered customers found in the field. To appreciate of the system loss since we operated the distribution system in Olongapo, this is the system loss level. As I mentioned a while ago, 37.2% in June, then went down to 22.6%. And then the lowest system loss we have was on March 2014, 14%. In average, our system loss since we started our operation is 22% or 21.8%. As I mentioned a while ago, that we only allowed to recover until 8.5%, meaning, as I said before, that OEDC is absorbing these losses from this system loss alone. So, as we see in this presentation, in average, 2,230,000 kilowatt hours. It's equivalent to 13,380,600 pesos. So that's the problem we have in the system loss in OEDC. Then another problem we have is the capacity problem. When we took over the operation, we found out that one of the substations in CBMU is almost overloaded. The CBMU 5MB 69 over 4.16 kV line is loaded almost 100% in 2011. And then we have also a problem in one of the substations, which is Cali substation, which has already a problem of voltage stop changer. In that effect, we cannot load fully the 15 MVA. So we can only load up to 7 MVA. Because if we load over the 7 MVA, the voltage quality of the customer will suffer. Another problem is the substation feeder. One problem that we have is we have two different voltages. We have 4.16 and we have another 13.8 kV systems. The 13.8 kV system serves the majority of the loads, which is equal almost to 85%. While for the 4.16, 15% of the loads was being served by this system. And then, as I mentioned also before, that there are feeders that are undersized, especially the backbone lines. Then there are feeders that are overloaded. Then many primary wires, plenty of splices na. Yung splices kasi, yan ang parang weak point sa isang linya. No? Marami siyang mga splices. Then wala, yung mga substation natin, walang mga aparatos to monitor the loading of its feeder and substation. Another problem is the unscheduled power interruption. I know everyone is experiencing this problem since we started our operation. In June alone, we incurred 41 unscheduled power interruption, which is very high. And then this unscheduled power interruption are mostly caused by broken, rotten, and defective wooden poles. No? Maraming mga poste na bulok na. Then, as I mentioned, maraming mga overloaded primary wires. Then, ang isang problema is the substation power transformers and feeders are not capable to handle N-1 contingency. In distribution utility operation standard, ERC, the regulator, allowed us to have allowed N-1, meaning to say, if we have 5 transformers, or we have 5 substations, if one substation back down or fail, the system should, the total capacity, remaining capacity should still capable to serve. That's an N-1 contingency. So in the event of one transformer, because I think the idea is, it takes time, Diwali, to replace a power transformer. It will take about 1 year. So that's the reason why the regulation allowed the distribution utility to have the N-1 contingencies as one of the planning criteria. And then another problem contributing this one is the substation capacity. In 2011, the substation capacity will be overloaded at 102%. Meaning, once yung 5 transformer, once yung isang transformer mag-back down, nasa full loading na tayo, nasa 102% na. So medyo critical din. Kailangan din siya i-address. Then, as we observe also, the feeders in Olongapo City are arranged in radial. Radial kasi parang wala siyang interconnection, hindi siya pwede mag-interconnect sa ibang mga feeders. And then, as I mentioned, the different primary voltage system na medyo hindi siya pwede mag-transfer ng mga loads sa ibang feeders. So this is the actual recorded power interruption and scheduled power interruptions. As I mentioned, in June 2013, there were 41 unscheduled power interruptions. Then it went down to 26, 39, 29, then 4. 23 November, then December 4. So ideally, we want to minimize these power interruptions, no? As much as possible below 4 power interruptions in feeder level in whole distribution system. So this is, I mentioned before, the arrangement of the distribution system. No? Our goal is to have a load distribution, meaning if one normal supply field, we have another alternative lines to connect that loads. Like for example, this is the portion of Santa Rita. Before, we only have one source of supplies sa primary line. Now, our plan is to have another line here. We have another line here. So, in the event mayroong problema dito, we can redirect our line going to another path. So, that's one of the advantages kung nakalock yung distribution system natin. Another problem is the undervoltage service. I know several customers are complaining about this problem. Undervoltage is defined kung ang actual voltage niya is beyond sa plus and minus 10%. No? Plus and minus 10% of the nominal voltage. If the nominal voltage is 230, so ang minus na is 23, is around 207 volts. No? If the voltage of the service is below 207, so we are already violating the standard rules. So that's one of the urgent things that we need to address for. Then, what are the causes? These are the causes that we initially determined. One is yung defective Kali substation. Limited lang yung capacity ang maibigay niya. Once we loaded more than 70%, mag-down na yung, mag-compromise na yung voltahe. And then, mayroon tayong overload substation feeders. Then yung mga distribution transformers, mostly owned by customer, are also located wrongly. No? Kasi yung planning kasi kung yung transformer dapat nasa center. Ang nangyari, yung iba, overextended na yung linya, malayo na yung customer. So malaki yung voltage drop. So nagsasuffer yung voltage quality ng service. So, knowing all those problems, in our part, it's very urgent. It's very urgent to improve this service, this problem, to improve our services. Like for example, in power interruptions, yes, we need to do how to minimize the power interruption. System loss, yes, we need to address that as immediately as possible. And all other problems that I mentioned before. So these are the 7 projects that we applied for implementation. First, to address the non-technical loss problem, the meter change out and the relocation of meters. The second is we need to establish the connectivity of the circuit to the customers. And then number 3 is we need to provide monitoring apparatus in all our substations. Then number 4, a need to upgrade the overloaded 5 MVA 4.16 kV transformer in CBNU. And the number 5 project is the necessary conversion of the CBNU 4.16 kV lines or system. By the way, this was the area covered by the 4.16 kV system before we converted this line. Wisbak Bahak and Wisbak Bahak, Barangay Wisbak Bahak and Wisbak Bahak. Then the next one is a need to upgrade or rehabilitate the primary line feeders of OEDC. Initially, we identified four feeders, which is the Cali feeder 1, CBNU feeder 1, Mercurio feeder 5, and Mercurio feeder 6. Along this project, there is also a replacement of rotten and defective poles for some insulators. And then the reconductoring of wires from smaller sizes to 56.4 MCM. The last project is the optimization of distribution transformer. This includes the